All right, so we're still going to factor, but we're kind of moving on from the factoring trinomials. We actually are still factoring trinomials, but we're going to be factoring the special case trinomials, and we're going to do all that in this one video, and that's going to be on 112 and 113. Okay, so I'm going to go ahead and turn and label 112 21.3 factoring special case trinomials, and I'm probably just going to put factoring special cases because I don't feel like writing a lot sometimes. All right, so page 112. 21.3 factoring special cases. I'll go ahead and label 113 as well. So we're going to be working on both today. We're going to write on 113, but we're going to do it foldable on 112 first. All right. I'm going to go ahead and fold this foldable so that the words factoring special products is still sticking out. So it looks like this. Okay, and then I'm going to cut on the dashed lines. So technically we've already done this before. The top two is not going to be like, if you don't remember how to do those, that's not going to be a big deal. I'm going to show you what I mean by that in a minute. And the bottom one is just a nice, you should be able to factor it really quick. So first we're going to talk about a perfect square trinomial, okay, when it's plus and plus. We're going to talk about 1, 2, and 3, and then we're going to go over and actually write the rule. So a perfect square trinomial, let's start number 1 by doing what we've done in the past, which is making a table. Now, I'm not going to have to make a table for the rest of these, and you're going to see that. C and B. C is 49, B is 14. Notice I don't have a number in front. Okay, so here's how this works. So I could do 1 and 49, but 1 plus 49 is 50, so that doesn't work. Okay, 2 won't go into it, 3 does not come out even, 4, nope, 5, no, 6, no, 7, yes, 7 and 7. And 7 plus 7 is 14. These are special for a reason. That means our factor is x plus 7, x plus 7. However, the final answer is x plus 7 squared because there are 2 of them. That is what we are actually doing. So on each of these, they are special because the last number c squared is, the last number c, sorry, is a perfect square, meaning I've got 2 of the same values here. For instance, in number 2, 121 is 11 times 11. Well, 11 plus 11 is 22. That means we would have x plus 11, which turns into x plus 11 squared. Okay, so this is actually what's going on. We're going to talk about the rule, and we're going to do number 3. The rule is it's whatever the a value is plus the b value times the same thing, a plus b, which means to find what goes here, we take the square root. So in number 1, the square root of x squared is x. We take the square root of b. The square root of b, which was 49, is 7. Then we are going to write it as a plus b squared. So we're going to use the rule for number 3. So the square root of 4 is 2. The square root of x squared is x. The middle number we don't worry about, plus the square root of 9 is 3. We write it again. And finally, we simplify so it's a squared. 2x plus 3 squared. These only work if it's a perfect square and a perfect square. and then 2ab here, meaning 2 times 3, which was 6, times 2, which was 12. All right, we're going to talk about the rule in perfect square trinomial when it's got a minus in the middle. It's the same thing. We will take the square root of a, so a squared, which is a, the square root of b, and we're going to put a minus between them this time because it's minus. Okay, my screen froze for a second there. There we go. All right, and finally we will make it as a minus b squared. So we're going to talk about number 4. All right, number 4, we have to make sure that it's actually in this form, meaning we have a square, yes, 9 squared. 2 times a times b is 2 times 9, 18, yes, so it works like this. So the square root of x squared is x, minus the square root of 81 is 9. And write it again. And then write it double, or sorry, as a squared piece. Number 5, x minus square root of 25 is 5, then double it. Or x minus 5 squared. Number 6, square root of 9 is 3, square root of 64 is 8, so 3 times 8 is 24, doubled is 48, so this is a special one. 3x, because square root of 9 is 3, minus square root of 64 is 8, and then double it. If you do not understand the trick, you can always make a table like we did the last couple of days. Okay, so all of these are perfect square trinomials, okay? And my screen froze again. So those are perfect squares. Let's talk about when it's not a perfect square trinomial. And that's the difference of 2 squares. Meaning, we do not have a trinomial anymore. We have 2 pieces. We have something squared minus something squared. We have to check and make sure we actually have that. Do we have something squared? Yes. Minus something squared? Well, yes. 6 squared is the same as 36. When we have that going on, our factors are a minus b and a plus b. They are literally the opposites. So, a, which is this, is x minus 36, the square root is 6, and then the same thing but with a plus between them. They're my factors when it's a perfect square, difference of 2 squares. Okay. Number 8, x squared minus 100. So is that a square? Yes. Minus 100, square root of 100 is 10, so yes, x minus 10, x plus 10. Okay, number 9, is that a perfect square? 25 is 5, 16 is 4, so that works. So 5x minus 4, 5x plus 4. All right, you're going to try some of these on your own in your notebook, and you're going to check them, so you're going to pause the video and try them on your own. Let's glue this to 112, and then we'll work on 113. All right, there's 112. Let's write on 113. We're not going to do very many examples. We're going to do a couple of each. I'm just going to start with number 1, and you're going to work them on your own. X squared plus 2x plus 1, and I'm going to skip down and put number 2. Let me make sure we didn't already do that one. We did. We didn't do that one. X squared minus 8x plus 16. And then number 3. And notice I'm kind of matching them up. I'm spacing them so that they match with what special case they were. 4x squared minus 64. All right, pause the video. I want you to try these three special cases. You've got x squared plus 2x plus 1, x squared minus 8x plus 16, and 4x squared minus 64. All right, let's talk about number one. Number one is a perfect square trinomial, meaning this is a square, and then the number in the middle is 2 times the squared pieces. So I have x squared, the square root of that is x, plus, because everything's plus, and the square root of 1 is 1. And then I double that. Now remember, to get the final answer, I'm going to write x plus 1 squared. Okay. Number 2, this is squared, this is 4 squared, and 4 times 2 is 8, or we need a negative, which means we'll have a negative between the two. So this one is perfect. X minus 4, x minus 4. Remember, we want to write it as x minus 4 squared. Okay. And last, our difference of two squares. You should have paused these and tried them. Square root of 4 is 2, so that is a perfect square. Square root of 64 is 8, so it's a perfect square, and it's a minus in between. If it is a plus in between, that doesn't work. 2x minus 8, 2x plus 8. And since they're not the same, remember, I can't write them as a squared. All right, you are going to work on an assignment I'm going to give you. That's kind of the end of factoring. Tomorrow we're going to be talking about solving these. So we're finally going to be moving on to solving these. I'll see you in the next video. Work on the assignment you are given.